Check the screen. Screen is visible?
Yes, sir.
Okay. So we'll start the session. We have started the module number 1. In the module number 1, so we have already completed the soil exploration. And in soil exploration, we have discussed about the objectives and importance of soil exploration. And again, samples, soil samples, again in that disturbed, undisturbed and representative samples. Then to collect the samples, what are the samplers are been using? Those also we have discussed. And geophysical methods, various methods of soil exploration we have discussed. Even geophysical exploration and borehole log also we have discussed. So in today's session, I am going to discuss about the bearing capacity and various definitions. It is very, very important for you how to calculate the bearing capacity and all. So this part is very important. Okay, and here generally we talk about the safe bearing capacity, the SBC of a soil. Before designing any of the footings, first we need to calculate the SBC of the soil. To calculate the SBC of soil, so I need to collect the sample first from the site, then those samples to be tested in the lab, and finally we get the SBC of the soil at that particular site. We get then what is the settlement pressure, then what is allowable bearing capacity, then types of foundation soil failure, how the foundation soil fails, that also we are going to discuss. Then the Targis and Bureau of Indian Standard Equations to calculate the bearing capacity. So that is their universal. There are various methods to calculate the bearing capacity, but out of those methods only they have mentioned two methods of calculating the bearing capacity are Targis and Bureau of Indian Standard. What they are prescribing to calculate the bearing capacity of a soil, that is to be discussed. Then coming to the effect of water table, how it affects the water table for the bearing capacity of the soil, and its eccentricity also, how it affects, that we are going to discuss in this particular chapter, that is bearing capacity chapter. Then there are some field methods they are given here. And what are those field methods? They are the plate load test to calculate the bearing capacity of the soil, and also the standard penetration method, static and dynamic penetration tests, and also the introduction to bearing capacity of layered soils. So these many methods we are going to discuss. Okay, so these are the field methods to calculate the bearing capacity of the soil. I hope my voice is audible to you all.
Yes, sir.
Right. So this is the syllabus of bearing capacity chapter. So coming to the bearing capacity, so you all know the bearing capacity. You heard the word, the bearing capacity of a soil in geotechnical engineering in your UG level. The bearing capacity, I think you learned also. That is the supporting power of a soil or rock, what we call as a bearing capacity. So with respect to this, various definition to be defined. And before going to calculate the bearing capacity by different methods, since you all are PG students, so you need to study in detail about the bearing capacity. Then before calculating the bearing capacity by using the Targis method or Bureau of Indian Standard method, so we'll define some of the terms which are very much related to the bearing capacity. They are the foundations and the footings, and the related definitions we'll first discuss, and later we go for the bearing capacity of the soil. So you all know a structure is essentially consists of two parts. So you all know a structure is essentially consists of two parts, namely the superstructure, which is above the plinth level, and the substructure, which is below the plinth level. You all can see this picture here, and this is the ground level, and above ground level you have this is what we call as a superstructure, and below the ground level whatever the structure is lying, it is called as a substructure. Okay, so this is a structure which is essentially consists of two parts. One is a superstructure, other one is a substructure. Then again in the substructure you will get the foundation, footing and foundation soil, and these all things you will get. Again a substructure, what is a substructure means, or it is called as a foundation. What is that substructure or a foundation? Is the part of a structure that is usually placed below the surface of the ground to transmit the load from the superstructure to the underlying soil or rock. That is what we call as a substructure. Then generally about 30% of the total construction cost is spent on the foundations. Whatever the structure lying above the ground is called as a superstructure. The structure which is lying below the ground is called as a substructure. Then coming to the footing, what is footing? What is its function? Footings are those parts of the foundation which resting directly on the soil. You can see in picture, and supports a specific portion of the building and distributing the building loads directly to the soil. So this is very important, the distributing the building loads directly to the soil. Okay, and the footing sizes and all, it depends upon the SBC of a soil, what we calculate, that is the bearing capacity of soil, what we calculate, and based on that value, the dimensions of the footing we get, and the function of this footing is to distribute the building load uniformly over the soil. Okay, then the most efficient footing and the foundation system is that which transmit the building loads to the soil without exceeding the bearing capacity of the soil. Means whatever the load coming on the structure, it should be safely transferred through the column, then through the footing and footing to the soil. So while transferring, the soil should not fail. Means whatever the load it transfers, it should not exceed the bearing capacity of the soil. So that bearing capacity of the soil, so we need to calculate for the different kinds of soil, and we need to recommend the different footings also for different kinds of soil. So coming to the next one, you all know whenever the load is being applied over the structure, what will happen? All soils get compressed noticeably when loaded and cause the supported structure to settle. So whenever this load is being applying over the structure, so what will happen? This will compress the soil down. Then what will happen? The supported structure may get settled. So if soil sufficient bearing capacity, if soil is having a sufficient bearing capacity which is lies immediately below the structure, then the load can be spread by footing as shown in the figure. So okay, so how the load can be spread under the footing, you can see here. So it is spreading in this way. So the load is being spreading here. Okay, so whenever the load is being spreading, it should not fail immediately. So for that, footing should be designed properly here to distribute the load. Then coming to the next one, a foundation. So you all know foundation, what is the definition of foundation, and how it can be used to transfer the loads and all. So here a foundation is that part of a structure which transmits the weight of the structure to the ground, and even all the structures constructed on land which are supported on the foundations. And a foundation is therefore it is a connecting link between a structure and the ground which supports. And here a foundation is an integral part of a structure. Here foundation is an integral part of the structure, and the stability of the structure which depends upon the stability of the supporting soil. So the stability of the main superstructure which is depending upon what? The stability of the supporting soil. And the two important factors that are to be considered are the foundation must be stable against a shear failure of the supporting soil. Means the soil below does not fail in shear. And the second criteria is what? The foundation must not settle beyond the tolerable limit to avoid the damage to the structure. Means the settlement is within the safe limits. Okay. Then the pressure which is the pressure which the soil can safely withstand is known as allowable bearing pressure, and that allowable bearing pressure we are going to calculate in this chapter. So I hope it's clear. Foundation in its importance, all of you.
Yes, sir.
Please note it on this one. Okay. Then what are the requirements for the foundations? So before providing any of the foundations, or before designing any of the foundation, what are the requirements you need to understand? So they are: the loads must be carried by the foundation system, which would include the dead load of the building and live load of the occupants and also its contents. Then what means, before designing the foundation, these are the requirements. You need to consider all the loads coming on the structure. Then the foundation system must register lateral loads from both ground pressure and wind, and also provide anchorage for the building superstructure against the uplift and raking force. Raking force means the tilt force what we get during the seismic action, or during the earthquake, or during the wind force. Whenever the component of building get tilted, then you will get the raking force. So a foundation system must resist all the lateral loads coming on it from both ground pressure as well as the wind pressure. Ground pressure means from the earthquake, and wind pressure, and provide the anchorage for the building superstructure against the uplift and the raking force. So these are the requirements. And coming again, continuing with the requirements, the most critical factor in determining the foundation system of the building is the type and bearing capacity of the soil. It's a very important. Again, I'm stressing here, type and bearing capacity of the soil. That is the one of the requirement to design the foundation, which the building loads are distributed. So based on the bearing capacity of the load, and we give the dimensions for the footing, and those footings will distribute the load evenly underneath the footing. That is, it should be adequately safe. The most critical factor in determining the foundation system of a building is the type and bearing capacity of the soil to which the building loads are distributed, and that is what we call as adequate safety it should possess. Then whenever foundations are to be designed, they should give a smaller settlements. They should not settle more. That is, the total and differential settlement should be very small. And even we come across some of the construction problems, and those also to be taken into account while designing the foundations. They are the stability of excavation, bottom heave, and also the groundwater problems you may come across, and those are to be taken into account. And these are the requirements for the foundation design. Even economical requirements also, how much is the budget allotted for the substructures, those all things to be taken into account before deciding any type of the foundations. So these are some of the requirements for the foundations. Okay. Then coming to the types of foundations, you all know about the types of foundations. Foundation may be broadly classified into two categories. They are the shallow foundations and the deep foundations. Even a shallow foundation which transmits the load to the strata at shallow depth, it is called as a shallow foundation. And a deep foundation transmits the load at a considerable depth below the ground surface, and it is called as a deep foundations here. So the shallow foundations, the examples are the spread footings, combined footings, and mat foundations. These all come under the shallow foundations. And the deep foundations are the pile foundations, and pier foundations are the deep foundations. And just look at the picture here. Here I am showing you the shallow foundations. It is shallow at depth, and these footings are used to distribute the load over the soil. See, look at this picture here. This is the foundation soil and this is the shallow foundation here. So the shallow foundations, there are various types. They are the combined footings, even the strap footing or the cantilevers footings like this. Combined footings, when two or more footings are columns are placed over a single slab, that it is called as a combined footing. And here the strip footing or continuous footings. So these all are the shallow footings or shallow foundations. So here you can see the isolated footing, so which is a shallow foundations. So an isolated footings here, you can see here the shallow foundation, the strip footing here, and the combined footing here. You all know when and where these kind of footings will be provided. So just I am discussing about here the types of footings and to decide this kind of footings, whether the combined footing or the strip footing or the isolated. So again, it all depends upon the bearing capacity of the soil, what we calculate from the site. Again, here the combined footing, you can see here the combined footings. These are the combined footings. So whenever the soil or the bearing capacity of the soil is very, very low, or one of the column is coming over the property line, so that time the combined footing will be using. Again, the rectangular combined footing is there, the trapezoidal combined footing is there. There are various criteria to decide various types of footings here. This is the raft or the mat foundations. Strip footing in both directions may be sufficient to spread the load and reduce the soil pressure to acceptable levels. If not, a raft foundation may give a suitable bearing pressure. Okay, so this is a strip footing here. This one is showing the strip footing, and this is the raft foundations. See, it is completely a slab. So when the footings are coming very closer to each other, or the soil below it is having a very low bearing capacity, in that time all the columns are placed over one single slab, that is called as a raft or the mat foundations. Or you may go by using the strip footing in both the direction like this. And for this all strip footings, the only one slab is been placed underneath. So this is called the raft or the mat foundations. For this also you would required to calculate the bearing capacity, and based on that only the foundation will be deciding. Again, this is the deep foundations. Here if a soil pressure has an insufficient bearing capacity, then it is necessary to use a deep foundations such as pile foundations, or to transmit the load to a deeper till the firmer strata. Okay, firm strata you need to take the that is boring, and then the foundation to be laid. So if a soil pressure has an insufficient bearing capacity, then it is necessary to use a deep foundation such as a pile to transfer the load to a deeper and firmer strata. These are the deep foundations. So this is the group of piles which are being placed again here. This is also called as the deep foundations. Then coming to the bearing pressure under the footings. So again from here the actual the syllabus starts here. So this is again very important. The bearing pressure under the footings. So actual pressure is not uniform. So whenever a load is being applying over the footing, it is not actually uniform. But for the design purpose, for the analysis purpose, we assume the pressure acting underneath the footing is uniform. For easy approach, we assume the pressure is uniform. So why it is not uniform? Because of the footing flexibility, and also the depth of footing below the ground surface, then also the type of the soil. So these all on these three factors, the actual pressure is not uniform. Okay, then so taking the first one for cohesion soils. If you take a cohesion soils, like a clay soils. If you take, so whenever a footing is being placed over the cohesive soil, then the load is being applying over that. What will happen? For a concentrically loaded pad footing, the bearing pressure distribution for a cohesive soil is the pressure are higher near the edge because the load produces a shear resistance around the perimeter, which adds to the upward pressure. So whenever a load is being applying, so on this side, so when the load is applying, so you will get the bending moment like this. Okay, so like this you will get. So here it's a sagging and here it is a hogging. Okay, then it means the pressure here is more you will get. It's not a uniform here. So for a cohesive type of a soil, so this is the representation of the soil pressure underneath. So here it is not uniform under this one. This is for the cohesive soil. And if you take the cohesion-less soil, that is for a sandy soil, so what will happen? The pressure here, the cohesion-less soil, the pressure are higher at the center. The pressure will be more at the center here. Here it is more at the center because the individual grains of the soil at the perimeter can shift very slightly outwards to where the soil stresses are less. So here this portion is subjecting to maximum stress. So that's why you will get with the more the soil has been subjecting to more stress here. So again you will be getting the non-uniform stress underneath the footing for the cohesion-less soil. Then coming to the for the design purpose, as I said, for the design purpose, provided the load is symmetrical with respect to the bearing area, it is usual to disregard these variations and assume an uniform bearing pressure. Means whatever the pressure we are getting in reality for the cohesive soil as well as for the cohesion-less soil, we are getting these kind of the pressure distribution under the footings. But for the design and analysis purpose, so we are neglecting these two kinds of variations and we are assuming that the load is acting at the center and distributing the load uniformly underneath, and the soil pressure is also uniform from one end to the other end. And this soil pressure, what we call as the bearing pressure of the soil, which is uniform. And axially loaded footings means the load is being acting at the center and it is passing through the CZ of the footings, and hence it is assuming that the pressure is acting uniformly over the soil. Okay, so see, for the analysis purpose, for the design purpose, the load beneath the footing is assumed as uniform. Then again to calculate the safe bearing capacity, some of the that is safety measurements that is to be considered. The footing should be safe against the overturning, that is called as a stability criteria to be taken into account. The foundation and the retaining walls. The foundation and the retaining walls must be designed to resist both overturning and sliding. So many a times whenever the load is not axially acting or not passing through the center, if it is eccentric, okay, if instead of acting a concentric, if it is acting eccentrically, then there is a chance of getting a footing to overturning. So in that case it should be stable. Okay, so that is overturning means to prevent overturning, the restoring moment due to the vertical load must be greater than the overturning moment. Means whenever the load is acting eccentrically, the vertical load whatever acting, it should be more to resist the overturning moment. So since it is acting in this way, so this side footing will be experiencing more pressure, okay, here. So that's why these are the values of the pressure here is more. This is Q max and this is the Q minimum. Okay, so next again sometimes you have to check against the sliding also. To prevent the footing from sliding, the resisting of footing on the soil must exceed the applied horizontal loads. Okay, so here the horizontal force is acting in this way. To resist this one, there should be a frictional resistance between the footing, that is a concrete, and the soil here. So here, look at this picture here, the same, where FR represents the frictional resistance under the base. In this way, it is acting frictional resistance, and horizontal force is acting in this direction. And this FR is given as R tan delta plus CA into AF. And here, where delta is the friction angle between the concrete and the soil, and EP is the passive resistance due to horizontal movement, and EA is the active resistance due to horizontal movement. So to prevent this footing from the sliding, so this load, that is load due to the frictional resistance, load due to the passive resistance, that is you heard about the passive pressure and active pressure and all, and minus the active pressure, when you take the all together, it should be greater than the horizontal force. Means whatever the force is acting here, if these all are greater than this force, then this will be safe against the sliding. So that is also to be taken into account while designing the foundations and all. And again, it depends upon the bearing pressure of the soil, that is safe bearing pressure of the bearing capacity of the soil. Then coming to the bearing capacity of the soil, so how it can be defined? It is defined as the maximum load which is acting per unit area which the soil will resist safely without the displacement, what we call as a bearing capacity of the soil. As I said previously, the bearing capacity means the supporting power of a soil or the rock, what we call as a bearing capacity. So here it is defined as the maximum load per unit area which the soil will resist safely without any displacement or any damages or any settlement. Then the bearing capacity of the soil can be found by loading the soil. First to load the soil, noting the settlement, and then by dividing the maximum load by the area on which the load is applied. Means whenever you want to calculate the load, so it is to be the load to be bearing capacity. If you want to calculate, if you have to apply the load, then whatever the load you are applying on what area you have to calculate, then that load by area gives you the bearing capacity of the soil, okay, or the pressure of the soil. The bearing capacity of the soil can be found by loading the soil, noting the settlement, and by dividing the maximum load by the area on which the load is applied. Okay. Suppose this is the load acting P. If this is the area A, then the bearing capacity will be what? P by A, load by area. This is the bearing capacity of the soil. Then coming to the bearing capacity of soil, some main components of the structures which including the soil. They are the foundation soil. Here the foundation soil we are taking. So we already discussed about the superstructure. The structure which is above the ground level is called as a superstructure. The structure which is lying below the ground level is called as a substructure. So in that substructure again comes various components. They are the foundation soil will come, again the foundations, footing. So these all terms to be defined. Here the foundation soil is that portion of the ground. Here this is the foundation soil which is subjected to additional stresses when foundations and superstructures are constructed on the ground. That is called as a foundation soil. Then again coming to some of the definitions. Basic definition you need to understand before calculating the bearing capacity of the soil. You need to understand some of the basic terms. What are those? Footing. So what do you mean by footing? A footing is a portion of the foundation of a structure that transmits the load directly to the soil. Okay. Then second one is a foundation. Again already it is defined a foundation. A foundation is that part of the structure which is in direct contact and transmits the load to the ground. That is the function of the foundation, to transfer the load uniformly over the soil. Then the foundation soil, so you can see that this is the foundation soil. What is the function of it? It is the upper part of the earth mass carrying the load of the structure. That is the function of the foundation soil. It is the upper part of the earth mass carrying the load of the structure. Then coming to the bearing capacity. So after defining some of the basic terms, footings, foundations and foundation soil, what is the bearing capacity means? The supporting power of a soil or a rock, which is referred as a bearing capacity. The supporting power of a soil or a rock is referred as a bearing capacity. Then again, try to understand the bearing capacity, since this chapter is entirely the calculation of bearing capacity by using the Terzaghi method or the BIS method. So why I have gone through the basic things is to understand the bearing capacity. What does it mean exactly, and what is the definition of it? And corresponding to this bearing capacity, we are going to define various terms like ultimate bearing capacity, net ultimate bearing capacity, net safe bearing capacity, then the settlement pressure, and all. We need to calculate the gross pressure, net pressure, how you can understand. So if you know the basic things about this one, you can understand easily the bearing capacity of the soil. So here, if a footing is subjected to two great loads, some of the soil supporting it will reach a failure state, and the footing may experience a bearing capacity failure. Means whenever a footing is been subjecting to load, sometimes this footing may exert a maximum pressure, and that pressure, what we call as a bearing pressure, and this footing is been supporting over the soil, and hence the bearing capacity is the what? Limiting pressure. It is a limiting pressure that the footing can support. If suppose if the load exceeds than the bearing capacity of the soil, then the footing will fail here. Either it may fail in shear, or it may fail by settlement. Okay, so this is what we call as a bearing capacity. The bearing capacity is the limiting pressure that the footing can support. You all can see the picture here. This is the footing, and over that footing the load is being applying, and this load is withstanding by the supporting soil by distributing the pressure uniformly on the soil. Hence the load or the pressure developed under the foundation without introducing any damaging moment in foundation and in the supported structure is called as bearing capacity of the soil. I'll repeat once again. The load or the pressure developed under the foundation without introducing any damaging moment in foundation and in the supported structure is called bearing capacity of the soil. Then you need to understand two terms, very important: gross and net soil pressure. Okay, so you all heard about the gross pressure or the net soil pressure. So what are these pressures? So again, also where to use gross soil pressure and net soil pressure in foundation design. So very important, the definitions: the gross soil pressure and the net soil pressure. So here I have given two pictures. You all can see these images. Clear?
Yes, sir.
Okay, so here I have given the two pictures. One is for the gross soil pressure, and another one is for the net soil pressure. Okay, so how we can calculate the gross soil pressure and the net soil pressure here? So taking to the first one here, this is the ground level. This one is the ground level, and from the ground level to the footing level it is marked here, and D represent the depth of the footing here, and over the footing a pressure due to weight of the soil is acting. So here this is the ground level. Okay, and the soil is filled here completely. The soil is being filled here. This is soil filling. Because of this soil, a footing is exerting, or a footing is being subjecting to a pressure due to what? The weight, due to what? The weight of the soil here. And also some more pressures are acting here. What are those pressures? The pressure due to weight of the footing, also column loads. Whatever the load is coming on the column, because of that, as well as the self weight of the footing, a pressure is also acting here. Then the gross soil pressure means what? It includes both the pressure due to weight of soil as well as the pressure due to weight of footing and the column load, whatever is acting and which is being subjecting beneath the footing, and that pressure what we call as a gross pressure again. Okay, then coming to the net pressure. So again, excluding this that is weight due to the that is soil, that is a pressure due to the weight of the soil, and the self weight is to be neglected, and only the load which is to be acting over the column, that is to be considered, and which is being subjecting beneath the footing, and that pressure is called as a net pressure. And how we can understand this gross and net pressure? Just here the soil pressure can be expressed as a gross soil pressure and the net soil pressure. And considering this figure here, it is marked as a ground level here. From the ground level to the footing level, it is also marked here, and D represent the depth of the footing, and also the soil is filled over the footing up to the ground level. The soil is filled here, and with this we have to calculate the gross soil pressure as well as the net soil pressure. Then the gross soil pressure, what is the definition of gross soil pressure, what it includes, and how to calculate the gross soil pressure? So it is the total soil pressure which includes pressure due to the column load, whatever the load is coming on the column. P, self weight of the footing, means the dead weight of the footing you have to take. Then the self weight of the soil from the ground level to the foundation level, means from the ground level to the foundation level, whatever the soil you have filled, that is to be calculated. So pressure due to the weight of the soil, it is marked here. This is the pressure distribution over the footing, and also the pressure due to the weight of the footing and column load, again it is marked here. And due to these three loads, that is pressure due to the column load, then the self weight of the footing, and self weight of the soil from the ground level to the foundation level. So the sum of these all, what we call as a gross soil pressure at the bottom of the footing. Then what is the net soil pressure? Net soil pressure here, it is the total soil pressure which does not include, so I'll repeat, it is the total soil pressure which does not include self weight of the footing, then the self weight of the soil from the ground level to the foundation level. Then the net soil pressure consists only pressure due to the column load. So net soil pressure will be consisting of only pressure due to the column load. Here the gross soil pressure, I hope you understood the gross soil pressure here. Then you can understand this by taking one example here. So here I given one example. Just take the load coming on the column is 1200 kilonewton. The load is 1200 kilonewton, and the footing size mentioned here is a 2.5 meter by 2.5 meter, and also the footing depth of the footing is 600 millimeter, and the depth below ground level to footing level, it is given here. From the ground level to footing level, it is given as a 1.5 meter, and also the unit weight of the soil is mentioned here. That is a gamma is mentioned here. This is the gamma. Unit weight of the soil is the 18 kilonewton per meter cube. Also the unit weight of concrete is given here, 25 kilonewton per meter cube, which is this one, concrete unit weight. So here there are two cases are to be considered. One is the column without load and column with load. Then we need to calculate the gross and the net soil pressure with this example. So can anyone calculate what is the gross soil pressure and net soil pressure with this example? So here first you need to take the self weight of the soil, that is 18 kilonewton per meter cube, and depth is 1.5 meter. So you all know how to calculate the self weight. It is gamma into depth of footing. Okay, what is the gamma here? Gamma is 18, depth of footing is 1.5. When you multiply it, you will get the self weight of the soil. At least you remember this formula, gamma into df. basic equation, self weight
Yes.
of soil to be calculated, weight of the soil to be calculated, gamma into depth of the footing or depth of the foundation. Then self weight of the footing, how will you calculate? Again, the unit weight of the concrete is given here, the depth of footing is given, then that multiplied by the depth gives you the self weight of the footing. I hope it's clear to you all how these values have come.
Yes, sir.
So here, after calculating these two, coming to the column with load. If I consider column with load, what is the gross soil pressure? Okay. So what is the load acting on the column? 1200 kilonewton. Then what is the size of the footing given? 2.5 meter by 2.5 meter. What is the pressure due to column load? How much pressure it is inducing into the footing? Load by area. Is it clear? Is it clear?
Yes, sir.
This pressure is due to the column load by area. And also you have already calculated pressure due to the weight of the soil, already calculated. This is the pressure due to the weight of the soil acting on the footing. Is it clear? And this,
Yes, sir.
this pressure is what? There are two pressures here. One is pressure due to the weight of the soil. Other one is the pressure due to what?
The footing, sir.
Footing as well as column load, both. How much it is? From the column, how much the pressure is? 192. From the footing, how much it is? 15. Already calculated. Here it is calculated already. From the footing, how much is the self weight? 15. It is giving 15 kilonewton per meter square. But from the column, how much it is coming? Pressure per square meter area, 192. Then if you want to calculate the gross soil pressure, how will you calculate? It will be 27 plus 15 plus 192. So here, whenever you calculate the gross soil pressure, it should not exceed the allowable bearing capacity of the soil. Means how much you are allowing the that is the pressure of the soil, it should not exceed that limiting value. If it exceeding that one, then the foundation may fail. Okay. So this is how we need to calculate the gross soil pressure. You need to take pressure due to weight of the soil, pressure due to weight of the footing and column load. So this all gives you the gross pressure at the bottom of the footing. Then coming to the net soil pressure, how it can be calculated? As I said, the net soil pressure will be what? Here given. It includes only the pressure due to the column load. So you need not take the pressure due to the soil or pressure due to the self weight of the footing. You did not take. So you have to worry about only the pressure due to the column load, that is the live load. Whatever the load acting on the column, how much it is producing the pressure underneath the footing, that is what we call as a net soil pressure acting. Okay. So here the load is coming 1200 kilonewton, size of the footing is 2.5 by 2.5. Then the load by area gives you the soil pressure. That soil pressure is called as a net soil pressure. I hope it's understood, all of you. In net soil pressure, I have not included the soil pressure as well as the self weight of the footing. I have not included. Only I have taken the load coming on the column, that is live load divided by the area of the footing. That gives you the net pressure of the. Coming to the where to use a gross and net soil pressures in foundation design, where you need to utilize those two values in foundation design. So if you want to calculate the area of footing, if you want to calculate the area of footing, to calculate that area of footing, which should be based on the criteria of gross soil pressure. So if you want to calculate the area of footing, it should be based on the gross soil pressure not exceeding the safe bearing capacity of the soil. Okay, that time that gross soil pressure to be utilized to calculate the area of footing. And next, where to use the net soil pressure? So if you want to calculate the bending moments and shear strength or shear force in concrete footing are calculated based on the net soil pressure. Means whenever if you want to calculate the bending moment and shear force for the footings based on the soil pressure acting, that time we need to consider only the net soil pressure. That is, net soil pressure is due to what? The load coming on the column per unit area is called as a net soil pressure, and that is producing the bending moment and shear force in the footing. In that time, we need to consider the net soil pressure to calculate the bending moment and shear strength of the soil. If you want to calculate the area of the footing, the gross soil pressure is to be taken into account, and the area of footing to be calculated. Is it clear, the difference, gross and net soil pressure?
Yes, sir.
With this, again, define some of the terms, very important. You can note it down also. The ultimate bearing capacity. So what is it? What do you mean by ultimate bearing capacity? The ultimate bearing capacity is the gross pressure at the base of the foundation at which the soil fails in a shear. It is called as the ultimate bearing capacity. And also, one more way to define the ultimate bearing capacity is the maximum pressure that causes sinking of footing into the soil as a result of shear failure is called as the ultimate bearing capacity. Okay, so this is one term defined. Then again, the net ultimate bearing capacity, it is the net increase in pressure at the base of the foundation causes the shear failure of the soil. It is equal to the gross pressure minus the overburden pressure. So the net ultimate bearing capacity will be the ultimate bearing capacity, that is QU, minus the overburden pressure is what? It is due to the soil. Means whenever you are taking this is the foundation, this is the footing, so this is the ground level, and here will be the soil. Here the soil filled, it has a specific weight of gamma, and the depth is df. Okay, so you need to deduct this gamma into df is what? Overburden pressure. This is overburden pressure which is filled, the soil is filled here over the footing. That is to be deducted to get the net ultimate bearing capacity. It is a net increase in pressure at the base of the foundation that causes the shear failure of the soil. It is equal to the gross pressure minus the overburden pressure. This is the formula you have to remember. Net ultimate pressure. So where QU is the ultimate bearing capacity, that is gross unit weight of the foundation soil, then the DF is the depth of foundation. Then safe bearing capacity. So many a times we use this term, say SPC of soil. That is represented as a QS, the maximum pressure which the soil can carry safely. The maximum pressure which the soil can carry safely without the risk of shear failure is called as a safe bearing capacity of the soil. How it can be calculated? The safe bearing capacity will be the net ultimate bearing capacity divided by the factor of safety plus gamma into df. That is the overburden pressure to be taken into account, and you need to consider some factor of safety. Usually the factor of safety which is taken as 3 to calculate the safe bearing capacity of the soil. Okay, so this is the definition of safe bearing capacity: the maximum pressure which the soil can carry safely without the risk of shear failure is called as a safe bearing capacity of the soil. So based on this value SBCA of soil, the foundations or the footings are being designed, and the dimensions are to be given for the footings just to satisfy the bearing capacity criteria. Then allowable bearing capacity, here the pressure intensity which is considered safe both with respect to shear failure as well as the settlement is called as allowable bearing capacity. The pressure intensity which is considered safe both with respect to the shear failure and the settlement is called as allowable bearing capacity. Means whenever the soil is been subjecting to the loading, it should not fail by shear as well as should not get settle, or it should not get sink into the soil. That is called as allowable bearing capacity. Then the net safe settlement pressure. The net safe settlement pressure is what? It is the net pressure which the soil can carry without exceeding the allowable settlement. It is called as a net safe settlement pressure. Then the maximum allowable settlement generally varies between 25 mm and 40 mm for individual footings. So net safe settlement pressure, the definition is what? It is the net pressure which the soil can carry without exceeding the allowable settlement. Generally the allowable settlement will be 25 mm to 40 mm for individual footings. Then coming to the artificial method of improving the bearing capacity here. What are the artificial methods? These artificial method of improving the bearing capacity of the soil, because some soil may have a more bearing capacity. Some soil are very weak to take the load. Uh, Wherever you are getting the very weak soil and all, in that case you need to improve the bearing capacity of the soil. How you can improve the bearing capacity of the soil? Just by increasing the depth of the foundations. You have to go in depth till you get the hard strata, uh, and by that method you can increase the bearing capacity of the soil. And second is draining the subsoil water. If any water is present in the subsoil, it should be drained out properly, and hence you can improve the bearing capacity of the soil. And just by third one is just by compacting the soil properly, you can improve the bearing capacity of the soil. Also by confining the soil mass, you can improve the bearing capacity of the soil. By cement grouting also you can improve the bearing capacity of the soil. Also by injecting some chemicals like silicates, etc., you can improve the bearing capacity of the soil. There are so many methods to be used to improve the bearing capacity of the soil. Then see, look at this picture here. A load is being applying here. You can see here. So this is a failure of medium dense sand. See how the load is being applying here. So look at this one. A load is applying here. So for this load, how it is behaving. So this is a failure of a medium dense sand. So you can see the failures here. These are the failure modes. It will fail like this. It is failing here, and these are the some failure modes. Again, it is divided zone 1, zone 2, zone 3. Some of the failure zones we have divided, and these zones are based on the Tarzagi's failure criteria. So those things to be again discussed later. How it fails, the foundation soil, how it fails, we'll be discussing later. That is also a very important part. So here, based on that one, depending on the stiffness of the foundation soil and depth of the foundation, the following are the modes of shear failure experienced by the foundation soil. So what are the three modes of failure the foundation soil get experienced? They are the general shear failure, local shear failure, and the punching shear failure. So these modes of failure are very important for the examination point of view. So again, we'll discuss these failures later, the next class. About the modes of shear failure we'll discuss in the next class. Okay, this is just introduction about the bearing capacity of the soil, and some of the terms we have defined. Please go through that. You can refer any textbook for this bearing capacity of the soil.